So what do professional athletes, drivers with whiplash, soldiers who dispose of roadside bombs, and kids who play contact sports have in common? Give up? They all need to worry about TBI, traumatic brain injury, that can result from concussions. Brilliant young Harvard engineering professor Kit Parker served 2 tours of duty with the U.S. Army in Afghanistan. He recently returned to the lab, determined to find a way to protect his fellow soldiers and everyone else from the dangers of traumatic brain injury. Shining City visited Kit in his lab to learn more.
I did 2 tours in Afghanistan. I'm a reservist, Army, and someone tried to kill me with an IED on my first tour, so got interested in the problem. Traditionally, we've been a cardiac laboratory, but we started taking a look at the brain injury problem and seeing if some of the tools that we had would apply to it, and it turns out that maybe some of them would work.
Now, what happens to the brain when it's impacted by an IED?
You know, when the blast wave or shock wave couples into the body, this blast wave propagates up into the skull, and your brain slams forward against the inside of the skull. So traumatic brain injury doesn't necessarily have to be a penetrating head wound, but it happens all around us just about every day. Car accidents, abused children, and on the athletic fields.
And you're particularly concerned about the impact, the long-term impact of traumatic brain injury on our returning soldiers from Iraq and Afghanistan.
So we know these acute injuries can potentiate neurodegenerative diseases, dementia, Alzheimer's, Parkinson's disease. So we have a certain awareness of the casualties we have coming back from the battlefield today who've been blown up, and we have guys out there that have been blown up 10, 11, 12, 13 times at this point in time. But what we don't have an understanding for, but we know is coming, is this wave of neurodegenerative diseases that these soldiers, sailors, airmen, and Marines are going to present with. So a lot of our research in most laboratories is directed towards addressing those people that already have been diagnosed with a neurodegenerative disease. What we're interested in is the first hour after the explosion, right after that brain has bounced around inside the skull. What's the mechanisms for the injury? Where are the therapeutic opportunities?
So Kit, what's so special about intervening right after the injury?
We learned in Vietnam that the hour after the casualty has been wounded, that if we get them off the battlefield and treat them within that first hour, what we call the golden hour, they have a much higher probability of survival. So one of the things that we're interested in is what's happening within the golden hour or in the first 10 minutes after the wound, what we call the platinum 10.
So what are you simulating here exactly?
So you'll see, when the IED goes off and this shock wave couples into the body, the entire body feels some type of energy waveform come through it. The skull is this hard encasement for the brain, which is kind of a fluid. So when this wave propagates into the brain, it slams the brain against the skull, and it can bounce around inside the skull. So what we're trying to do is mimic this impact in a dish.
Okay. What would that be similar to doing? Is that that's similar to a bomb? Is it similar to a car accident? Is it similar to being hit with a lacrosse stick?
So you're asking a really good question, Carrie, because we don't know exactly what the magnitudes of the forces are inside the skull. The blast wave is being attenuated as it goes into the skull. We don't have exact numbers on that, so we try to mimic it as best we can.
And these pink dishes are tissues.
Right, so they can be neural tissues
like
or vascular tissue. Exactly.
And your goal is to find a treatment that can be given either during that golden hour or those platinum 10 minutes that does what?
That prevents the development of a neurodegenerative disease, Alzheimer's, Parkinson's, dementia.
And you think that this could be used not just for people off the battlefield, but also kids on the playing field, sports figures in professional sports.
Anyone who shows up at the emergency room who might have had a concussion or some type of brain injury would benefit from therapeutics that could evolve out of this research.
And someday you're imagining what, a pill you take or a shot that's given to somebody? And
there's several different ways. Pills, inhalants, there's a variety of different ways that you can maybe do this. I want to be clear though, we haven't identified the molecular targets yet. Well, what we first had to do was develop a set of assays or experiments so that we could start to identify what they are. I mean, this is a very poorly studied field. The Center for Disease Control had been saying for a long time before the wars in Iraq and Afghanistan that brain injury, traumatic brain injury was a problem because people were surviving, car accidents because of three-point safety belts, but they were having brain injuries. So this problem's been around for a long time. It's been very poorly funded. Now we're hoping that as the Department of Defense and other government agencies start to pour some money at the problem, we will meet the hordes of scientists that come to study the problem with the right tools. So it doesn't matter if I solve the problem or someone else does. I mean, I just want the problem solved.